All right, this is earlier practice for the work and energy exam. During a certain time interval, a 20 Newton object. So this 20 newtons is the weight. Remember, if it's in kilograms, then it's the mass. Free fall is 10 meters. The object gains how many joules of kinetic energy? So basically what's happening is potential energy is being converted into kinetic energy. So if you can figure out how much potential energy was changed hands, so to speak, into kinetic, you have your answer. So P is mgh. Your mg you already have, that's 20 newtons. The h is 10 meters, so it's 200 joules of potential energy is lost as it falls. That's how much kinetic energy is gained. Next question. An object weighs 10 newtons, is dropped from rest from a height of 4 meters above the ground. When it is free falling 1 meter, its total mechanical energy with respect to the ground is. Total mechanical energy, it's not complicated, it's just PE and KE. So it's not heat or anything related to that, or internal energy, which is Q in your reference table. So if you're at 4 meters above the ground and drop from rest, that means this term is just mgh. So it's 10 newtons times 4 meters. You have 40 joules of mechanical energy. When it's fallen 1 meter, you're going to have some KE and a little bit less PE, but the sum of those two is still going to be 40 joules. Next question. Constant force of 1900 newtons is required to keep an automobile having a mass of 1 times 10 to the third kilograms moving at a constant speed of 20 meters per second. The work done in moving the automobile a distance of that much is, work is force times distance. The force required is 1900 newtons times 2 times 10 to the 3 meters is equal to 3.8 10 to the 6 joules. Diagram below shows a moving, so it's moving, a 5 kilogram cart, that's the mass, at the foot of a hill that's 10 meters high. For the cart to reach the top of the hill, what is the minimum kinetic energy of the cart in the position shown? So the kinetic energy here, the minimum, would mean that it would make it just to the top here and stop moving. That means all of the energy is potential because its V is 0, it's not moving. The KE at the top would be 0. So really what you want to figure out is this KE here has to equal the PE here. The PE at the top we can find, it's mgh. So it's 5 kilograms times 9.8 per second squared times 10 meters is 490 joules. That's how much energy is required down here. It's going to be converted to PE. I guess it's 491 if you don't round. You could have also been asked what's the velocity there, which you would have set the 490 equal to 1/2 mv squared and solve for what the V necessary to make it up the hill would have been. The diagram below, 400 joules of work is done raising a 72 Newton weight a vertical distance of 5 meters. So the first thing I'm thinking is they gave me Fg, which is mg, and they gave me h. I can calculate the PE. It's just mgh. If I do that, it's 360 joules. But they said it took 400 joules of work to do this. Let's read what the question is. How much work is done to overcome friction? There you go, that explains it. So it required 400 joules, but you only ended up transferring 360 joules of PE. The difference, that 40 joules, must have been overcoming friction.